Here's our math problem for today. Let's say we are given this exponential equation, 4 raised to x plus 2 raised to 2x minus 1 equals 3 raised to x plus 1 half plus 3 raised to x minus 1 half. Find the value of x. You can pause the video and see if you can solve this exponential equation. Now let's solve this problem together. Let's begin by recalling first two rules of exponents. When we are given a raised to m plus n, that is equal to the product a to the m times a to the n. And second, when we are given a raised to m minus n, that is equal to the quotient a raised to m over a raised to n. Now, look at this part here. This part is exactly the same as the second rule here. Then, looking at this second expression here, that is exactly the same in form as our first rule here. So let's apply these two properties in order to simplify our equation. So let's begin by simplifying 2 raised to 2x minus 1. That is equal to 2 raised to 2x divided by 2 raised to 1. Then we can rewrite 3 raised to x plus 1 half using this property here. That is now equal to 3 raised to x times 3 raised to 1 half. Notice that when you have minus here, that resulted to the quotient of the two exponential numbers. When there is a plus sign for this exponent, that resulted to the product of two exponential numbers. Then copy all the rest. Next, let's recall again another property. When we have power of power, that is a raised to m all raised to n, that is equal to the same base raised to the product of the exponents. This property can be used in order to simplify this part here, because this boxed expression here is the right side of this property. We can write that in the form the same as this left side. That is, we can raise 2 to the second first and then all raised to x. And so the result now is 2 raised to the second is equal to 4, then copy the exponent x. That is applying this property. Then copy all the expressions at the left side. Now, at the right side of this equation, notice that this 3 raised to fractional exponent 1 half and 3 raised to fractional exponent 1 half at the second expression at the right, we can write them in radical notation. That is equal to square root of 3. So the right side now becomes 3 raised to x times square root of 3 plus 3 raised to x over square root of 3. What we did was we rewrote 3 raised to 1 half as square root of 3. Next, let's look for common factors. Notice that 4 raised to x is a common factor at the left side, which we can factor out. And the other factor would be 4 raised to x divided by 4 raised to x is 1, plus 4 raised to x over 2 divided by 4 raised to x, that is equal to 1 half. Then at the right side, there's also a common factor 3 raised to x. Let's factor that out, and the other factor would be this expression divided by 3 raised to x will cancel 3 raised to x, so what's left is square root of 3 plus the second expression divided by 3 raised to x, that would result to 1 over square root of 3. So 1 plus 1 half is 3 halves, so the left side becomes 4 raised to x times 3 over 2. That is equal to 3 raised to x, then get the sum of these two terms. Square root of 3 plus 1 over square root of 3. The LCD is square root of 3, and multiplying square root of 3 times square root of 3, that is positive 3, plus 1 is 4, and then the denominator is square root of 3. There is a variable at the left side, and there is a variable at the right side. We want to gather all the variables in one side of the equation, and we can accomplish that this way. We divide both sides by 3 raised to x times 3 over 2. Then to simplify the left side, let's recall again another property of exponent. When we are given a raised to m over b raised to m, notice that the bases are different but the exponents are the same. That is equal to the fraction a over b all raised to the common exponent. So here, the base 4 and the base 3 are different, but the exponents x are the same. So applying now this property, that is equal to the fraction 4 over 3 all raised to x. And then at the right side, instead of division, we can rewrite this as multiplication. So we multiply 4 over square root of 3 by the reciprocal of 3 halves, which is 2 over 3. Then let's continue. At this point, we want to rewrite the right side in a form similar to the left side. That is, if we can write this as 4 over 3 raised to a certain exponent, then that exponent is equal to the value of x. And we can accomplish that by noting that 2 is just the same as square root of 4. So notice that you now have 4 times square root of 4 over square root of 3 times 3. So that we can see clearly what property we are going to use here, we can write that in fractional exponents. So in fractional exponent, square root of 3 is 3 raised to 1/2. Square root of 4 is 4 raised to 1/2. And notice that you now have the same base here, 4, and the same base, 3. So let's continue. When a number has no exponent, it's implied that the exponent is 1. And then applying now this property, that is the product a raised to m times a raised to n, that is 4 raised to the first times 4 raised to 1/2, that is equal to the common base a raised to the sum 1 plus 1/2. And so let's write that. 1 plus 1/2 is 3/2. We copy the common base 4. And then here, 3 raised to 1/2 times 3 raised to the first, we copy the common base 3, and we add 1/2 plus 1, which is also 3/2. And finally, let's recall again this property. So this form here is a raised to m over b raised to m. The bases are different, but the exponents are the same. This is just the same as writing this as the fraction 4 over 3 raised to the common exponent 3/2. Notice now that we have the same bases here. 4 over 3 raised to x equals 4 over 3 raised to 3/2. And then recalling one more property of exponents from the one-to-one property of exponential function. Since these two exponential numbers are equal and the bases are the same, then the exponents must be equal. And so we now know that x is equal to 3/2. And this now solves our exponential equation. So thank you very much, and we hope to see you again in our next video. Bye for now.